In this setup, we're going to talk about how you use the ATOS Q to scan small, high-detailed parts. The part that we have now is a precision graphite electrode, which is used for tool making. You'll notice here that we have the sensor mounted to the desk stand. This allows us to achieve the stability necessary to scan this sort of high-precision part. Another benefit to the ATOS Q is that for each and every measuring volume, the standoff distance is the same, at 490 millimeters. This is because we have one fixed camera angle that we use across all lens sets. This makes any of the lens set changes from the smallest to the largest measuring volumes very fast and easy. With this part, we've changed our lenses from the larger field of views we had earlier down to a measuring volume which is 170 by 130 millimeters. This means that all 12 million of our data points are crammed in that small area. This allows us to get a resolution, or the minimum point spacing between 2 points on our mesh, down to as low as 30 microns. In this sort of setup, you could also use the smaller measuring volume of 100 millimeters or a larger measuring volume like the 270 millimeter. Just like with the larger fields of view, scanning is very fast and intuitive. The precision calibration of the ATOS Q allows us to maintain the necessary accuracy and precision for a part like this one. Both manual and automated rotation table solutions are available for this type of setup. The ATOS Q is also taking advantage of GOM's triple scan technology. That means for every sensor position, we're looking at 3 different viewpoints. The first thing the system's going to do is take a look at what it sees from both cameras together. Then it's going to look at the left camera independently and then the right camera independently, so each side can cover what the other one misses. In order to do this, you need to have a precision calibrated 3D camera. The system will automatically combine all 3 different viewpoints for each scan, and this allows us to capture even hard to reach areas easily. So let's take a look now at the data that the ATOS Q got on this part. Here's the resulting mesh from that scan, and just take a look at how much detail we can get on that part. We can see here that the software automatically reduced the number of points on the flatter areas of the part, and on the curved areas we still get the maximum amount of detail. With the 170 millimeter measuring volume, even the smallest shape deviations will become visible on this electrode. We talked earlier about the triple scan principle. Here we can see the results from this technique. It's a very powerful feature of the ATOS Q, which allows us to scan deep into narrow pockets. The last thing I want to show you here is a color deviation plot of the top of the electrode. If you look on the right-hand side, you'll see that the total range here is just 10 microns. Now it's very easy to verify whether this electrode can be used for the EDM process or see if it has to be improved first. Now we've had a look at how we use the ATOS Q to scan small, precision parts. You'll also notice that the finish on this part is a dark black, and even this sort of surface we can scan quickly and easily with the ATOS Q.